Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are working at a sports association whose members range in age from 8 to 30. The association collects a large amount of health data, such as sustained injuries. You are storing this data in BigQuery. Current legislation requires you to delete such information upon request of the subject. You want to design a solution that can accommodate such a request. What should you do? The options are: Option A, use a unique identifier for each individual. Upon a deletion request, delete all rows from BigQuery with this identifier. Option B, when ingesting new data in BigQuery, run the data through the Data Loss Prevention (DLP) API to identify any personal information. As part of the DLP scan, save the result to Data Catalog. Upon a deletion request, query Data Catalog to find the column with personal information. Option C, create a BigQuery view over the table that contains all data. Upon a deletion request, exclude the rows that affect the subject's data from this view. Use this view instead of the source table for all analysis tasks. Option D, use a unique identifier for each individual. Upon a deletion request, overwrite the column with the unique identifier with a salted SHA-256 of its value.
To arrive at the correct answer, we focus on the keywords: BigQuery, delete such information upon request, accommodate such a request.
The correct answer is Option A, use a unique identifier for each individual. Upon a deletion request, delete all rows from BigQuery with this identifier.
Why is this correct? A. Executing a delete DML statement in BigQuery using a unique individual identifier permanently removes all rows associated with the subject, directly satisfying the legal requirement for data deletion. Why are the others incorrect? B. DLP API and Data Catalog help discover and classify sensitive data, but they do not delete the subject's record from BigQuery. C. Creating a view hides data from analysis queries but leaves the personal data stored in the underlying source table, failing to satisfy deletion laws. D. Pseudonymizing the identifier with a salted SHA-256 hash retains the health data and identifier structure, which does not satisfy full data deletion requirements.
Your company has announced that they will be outsourcing operations functions. You want to allow developers to easily stage new versions of a cloud-based application in the production environment and allow the outsourced operations team to autonomously promote staged versions to production. You want to minimize the operational overhead of the solution. Which Google Cloud product should you migrate to? The options are: Option A, App Engine. Option B, GKE On-Prem. Option C, Compute Engine. Option D, Google Kubernetes Engine.
To arrive at the correct answer, we focus on the keywords: stage new versions, promote staged versions to production, minimize the operational overhead.
The correct answer is Option A, App Engine.
Why is this correct? A. App Engine natively supports application versioning and traffic splitting, allowing developers to easily deploy staged versions and enabling the operations team to promote them to production with minimal operational overhead. Why are the others incorrect? B. GKE On-Prem is meant for hybrid on-premises Kubernetes deployments and introduces significant operational complexity and infrastructure management. C. Compute Engine is an infrastructure as a service (IaaS) offering that requires manual management of virtual machines, load balancing, and deployment strategies, greatly increasing operational overhead. D. Google Kubernetes Engine requires managing container orchestration, Kubernetes manifests, and deployment pipelines, which involves higher operational overhead than App Engine.
Your company is running its application workloads on Compute Engine. The applications have been deployed in production, acceptance, and development environments. The production environment is business critical and is used 24/7, while the acceptance and development environments are only critical during office hours. Your CFO has asked you to optimize these environments to achieve cost savings during idle times. What should you do? The options are: Option A, create a shell script that uses the cloud command to change the machine type of the development and acceptance instances to a smaller machine type outside of office hours. Schedule the shell script on one of the production instances to automate the task. Option B, use Cloud Scheduler to trigger a cloud function that will stop the development and acceptance environments after office hours and start them just before office hours. Option C, deploy the development and acceptance applications on a managed instance group and enable autoscaling. Option D, use regular compute engine instances for the production environment and use preemptible VMs for the acceptance and development environments.
To arrive at the correct answer, we focus on the keywords: acceptance and development environments, critical during office hours, cost savings during idle times.
The correct answer is option B, use Cloud Scheduler to trigger a cloud function that will stop the development and acceptance environments after office hours and start them just before office hours.
Why is this correct? B. Cloud Scheduler combined with Cloud Functions provides an automated, serverless method to stop VM instances outside office hours and restart them before work begins, eliminating compute charges entirely during idle times. Why are the others incorrect? A. Downscaling machine types still incurs compute costs for the smaller instance, requires restarting instances anyway, and running management scripts on a production instance introduces unnecessary operational risk. C. Standard autoscaling in managed instance groups reacts to resource utilization metrics like CPU load rather than fixed time schedules, so idle instances would still run at the group's minimum size. D. Preemptible VMs can be reclaimed by Google Cloud at any time with 30 seconds notice, which causes unpredictable disruptions during critical office hours.
You are moving an application that uses MySQL from on-premises to Google Cloud. The application will run on Compute Engine and will use Cloud SQL. You want to cut over to the Compute Engine deployment of the application with minimal downtime and no data loss to your customers. You want to migrate the application with minimal modification. You also need to determine the cutover strategy. What should you do? The options are: Option A, 1. Set up Cloud VPN to provide private network connectivity between the Compute Engine application and the on-premises MySQL server. 2. Stop the on-premises application. 3. Create a MySQL dump of the on-premises MySQL server. 4. Upload the dump to a cloud storage bucket. 5. Import the dump into Cloud SQL. 6. Modify the source code of the application to write queries to both databases and read from its local database. 7. Start the Compute Engine application. 8. Stop the on-premises application. Option B, 1. Set up Cloud SQL proxy and MySQL proxy. 2. Create a MySQL dump of the on-premises MySQL server. 3. Upload the dump to a cloud storage bucket. 4. Import the dump into Cloud SQL. 5. Stop the on-premises application. 6. Start the Compute Engine application. The options are: Option C, 1. Set up Cloud VPN to provide private network connectivity between the Compute Engine application and the on-premises MySQL server. 2. Stop the on-premises application. 3. Start the Compute Engine application, configured to read and write to the on-premises MySQL server. 4. Create the replication configuration in Cloud SQL. 5. Configure the source database server to accept connections from the Cloud SQL replica. 6. Finalize the Cloud SQL replica configuration. 7. When replication has been completed, stop the Compute Engine application. 8. Promote the Cloud SQL replica to a standalone instance. 9. Restart the Compute Engine application, configured to read and write to the Cloud SQL standalone instance. The remaining options are Option D, 1. Stop the on-premises application. 2. Create a MySQL dump of the on-premises MySQL server. 3. Upload the dump to a cloud storage bucket. 4. Import the dump into Cloud SQL. 5. Start the application on Compute Engine.
To arrive at the correct answer, we focus on the keywords MySQL from on-premises to Google Cloud, Compute Engine, and will use Cloud SQL, minimal downtime, no data loss, minimal modification.
View the options on screen. The correct answer is option C, 1. Set up Cloud VPN to provide private network connectivity between the Compute Engine application and the on-premises MySQL server. 2. Stop the on-premises application. 3. Start the Compute Engine application, configured to read and write to the on-premises MySQL server. 4. Create the replication configuration in Cloud SQL. 5. Configure the source database server to accept connections from the Cloud SQL replica. 6. Finalize the Cloud SQL replica configuration. 7. When replication has been completed, stop the Compute Engine application. 8. Promote the Cloud SQL replica to a standalone instance. 9. Restart the Compute Engine application, configured to read and write to the Cloud SQL standalone instance. Review the options on screen.
Why is this correct? C. Using continuous replication via Cloud VPN to a Cloud SQL external replica allows data to sync in near real time. Promoting the replica to a standalone instance enables a fast cutover with minimal downtime and no application code changes. Why are the others incorrect? A. Modifying application source code to implement dual writing introduces unnecessary complexity and violates the requirement for minimal code modification. B. Relying solely on a MySQL dump without establishing database replication causes significant downtime during the dump and import process. D. Taking a database dump while the application is stopped results in prolonged, unacceptably long downtime during the file upload and database import steps.
Your organization has decided to restrict the use of external IP addresses on instances to only approved instances. You want to enforce this requirement across all of your virtual private clouds, VPCs. What should you do? The options are Option A. Remove the default route on all VPCs, move all approved instances into a new subnet that has a default route to an internet gateway. Option B. Create a new VPC in custom mode. Create a new subnet for the approved instances, and set a default route to the internet gateway on this new subnet. Option C. Implement a Cloud NAT solution to remove the need for external IP addresses entirely. Option D. Set an organization policy with a constraint on constraints/compute.vm external IP access. List the approved instances in the allowed values list.
To arrive at the correct answer, we focus on the keywords, restrict the use of external IP addresses, approved instances, enforce this requirement across all of your virtual private clouds, VPCs.
The correct answer is option D. Set an organization policy with a constraint on constraints/compute.vm external IP access. List the approved instances in the allowed values list.
Why is this correct? D. Setting an organization policy with the constraints/compute.vm external IP access constraints centrally restricts which VM instances can be assigned external IP addresses by specifying allowed VM instances in the policy configuration. Why are the others incorrect? A. Modifying default routes controls traffic routing within subnets, not the assignment of external IP addresses to specific Compute Engine instances. B. Subnet routes manage packet forwarding to internet gateways, but they cannot enforce restrictions on external IP address assignment across instances. C. Cloud NAT provides outbound connectivity without external IPs, but the requirement mandates allowing external IPs specifically for approved instances rather than removing them entirely.
Your company uses the Firewall Insights feature in the Google Network Intelligence Center. You have several firewall rules applied to Compute Engine instances, you need to evaluate the efficiency of the applied firewall rule set. When you bring up the Firewall Insights page in the Google Cloud Console, you notice that there are no log rows to display. What should you do to troubleshoot the issue? The options are: Option A, enable Virtual Private Cloud (VPC) flow logging. Option B, enable firewall rules logging for the firewall rules you want to monitor. Option C, verify that your user account is assigned the Compute.Network Admin Identity and Access Management (IAM) role. Option D, install the Google Cloud SDK and verify that there are no firewall logs in the command line output.
To arrive at the correct answer, we focus on the keywords: Firewall Insights, firewall rules apply to compute engine instances, no log rows to display, troubleshoot the issue.
The correct answer is option B, enable firewall rules logging for the firewall rules you want to monitor.
Why is this correct? B. Firewall Insights relies directly on firewall rules logging to gather traffic metrics and analyze rule usage. Enabling logging on the specific firewall rules allows Firewall Insights to aggregate data and display log rows in the console. Why are the others incorrect? A. VPC flow logs track VM-to-VM network traffic flows, but Firewall Insights requires firewall rules logging specifically to evaluate firewall rule hit counts and optimization. C. IAM permission issues like missing Compute.Network Admin would result in an access error or restricted view rather than an empty set of log rows. D. Running command line tools like the Cloud SDK will not generate or display missing logs if firewall rules logging is disabled at the source.
Your company has sensitive data in cloud storage buckets. Data analysts have Identity Access Management (IAM) permissions to read the buckets. You want to prevent data analysts from retrieving the data in the buckets from outside the Office network. What should you do? The options are: Option A, 1. Create a VPC service controls perimeter that includes the projects with the buckets. 2. Create an access level with the CIDR of the Office network. Option B, 1. Create a firewall rule for all instances in the Virtual Private Cloud (VPC) network for source range. 2. Use the classless interdomain routing (CIDR) of the Office network. Option C, 1. Create a cloud function to remove IAM permissions from the buckets, and another cloud function to add IAM permissions to the buckets. 2. Schedule the cloud functions with Cloud Scheduler to add permissions at the start of business and remove permissions at the end of business. Option D, 1. Create a cloud VPN to the Office network. 2. Configure private Google access for on-premises hosts.
To arrive at the correct answer, we focus on the keywords: cloud storage buckets, identity access management (IAM), permissions, prevent data analysts from retrieving the data in the buckets from outside the Office network.
The correct answer is option A, 1. Create a VPC service controls perimeter that includes the projects with the buckets. 2. Create an access level with the CIDR of the Office network.
Why is this correct? A. VPC service controls combined with Access Context Manager allows you to define a security perimeter around cloud storage and restrict API access based on network attributes like the Office network's CIDR IP range. Why are the others incorrect? B. VPC firewall rules apply only to VM instances within a VPC network, not to Google Cloud Managed Service endpoints like cloud storage. C. Scheduling IAM permission changes restricts access by time of day, but still permits users to retrieve data from outside the Office during allowed business hours. D. Private Google access for on-premises hosts enables private routing to Google APIs via VPN, but it does not block public access attempts originating outside the VPN.
You have developed a non-critical update to your application that is running in a managed instance group, and have created a new instance template with the update that you want to release. To prevent any possible impact to the application, you don't want to update any running instances. You want any new instances that are created by the managed instance group to contain the new update. What should you do? The options are: Option A, start a new rolling restart operation. Option B, start a new rolling replace operation. Option C, start a new rolling update. Select the proactive update mode. Option D, start a new rolling update. Select the opportunistic update mode.
To arrive at the correct answer, we focus on the keywords, managed instance group, new instance template, don't want to update any running instances, new instances that are created by the managed instance group to contain the new update.
The correct answer is option D, start a new rolling update. Select the opportunistic update mode.
Why is this correct? D. Opportunistic update mode applies the new instance template only when new instances are created, such as during scale-out events, leaving currently running instances completely untouched and unaffected. Why are the others incorrect? A. A rolling restart restarts existing instances, directly impacting currently running instances contrary to the requirement. B. A rolling replace actively terminates and replaces existing running instances with new ones, disrupting the running application. C. Proactive update mode automatically and immediately rolls out the updated template to existing running instances, which violates the requirement to leave them untouched.
Your company is designing its application landscape on Compute Engine. Whenever a zonal outage occurs, the application should be restored in another zone as quickly as possible with the latest application data. You need to design the solution to meet this requirement. What should you do? The options are: Option A, create a snapshot schedule for the disk containing the application data. Whenever a zonal outage occurs, use the latest snapshot to restore the disk in the same zone. Option B, configure the Compute Engine instances with an instance template for the application, and use a regional persistent disk for the application data. Whenever a zonal outage occurs, use the instance template to spin up the application in another zone in the same region. Use the regional persistent disk for the application data. Option C, create a snapshot schedule for the disk containing the application data. Whenever a zonal outage occurs, use the latest snapshot to restore the disk in another zone within the same region. Option D, configure the Compute Engine instances with an instance template for the application, and use a regional persistent disk for the application data. Whenever a zonal outage occurs, use the instance template to spin up the application in another region. Use the regional persistent disk for the application data.
To arrive at the correct answer, we focus on the keywords, Compute Engine, zonal outage, restored in another zone as quickly as possible, latest application data.
The correct answer is option B, configure the Compute Engine instances with an instance template for the application, and use a regional persistent disk for the application data. Whenever a zonal outage occurs, use the instance template to spin up the application in another zone in the same region. Use the regional persistent disk for the application data.
Why is this correct? B. Regional persistent disks synchronously replicate data across two zones within the same region. Combining them with instance templates allows rapid failover to another zone with zero data loss during a zonal outage. Why are the others incorrect? A. Restoring a snapshot in the same zone does not resolve a zonal outage, as that zone remains unavailable. C. Snapshot schedules are asynchronous and periodic, leading to potential data loss, RPO, and slower recovery times compared to synchronously replicated regional persistent disks. D. Regional persistent disks are scoped to a specific region and cannot be attached to Compute Engine instances in a different region.
Your company has just acquired another company, and you have been asked to integrate their existing Google Cloud environment into your company's data center. Upon investigation, you discover that some of the RFC 1918 IP ranges being used in the new company's Virtual Private Cloud, VPC, overlap with your data center IP space. What should you do to enable connectivity and make sure that there are no routing conflicts when connectivity is established? The options are: Option A, create a cloud VPN connection from the new VPC to the data center, create a cloud router, and apply new IP addresses so there is no overlapping IP space. Option B, create a Cloud VPN connection from the new VPC to the data center, and create a Cloud NAT instance to perform NAT on the overlapping IP space. Option C. Create a Cloud VPN connection from the new VPC to the data center, create a cloud router, and apply a custom route advertisement to block the overlapping IP space. Option D. Create a Cloud VPN connection from the new VPC to the data center, and apply a firewall rule that blocks the overlapping IP space.
To arrive at the correct answer, we focus on the keywords RFC 1918 IP ranges, virtual private cloud, VPC, overlap with your data center IP space, no routing conflicts.
The correct answer is option A. Create a Cloud VPN connection from the new VPC to the data center, create a cloud router, and apply new IP addresses so there is no overlapping IP space.
Why is this correct? A. Resolving IP range overlaps requires readdressing resources with new, non-overlapping IP addresses. Establishing a Cloud VPN with Cloud Router alongside non-overlapping IP space ensures proper routing and seamless connectivity between the VPC and data center. Why are the others incorrect? B. Google Cloud NAT is designed for outbound internet access from instances without external IP addresses, not for resolving overlapping RFC 1918 IP space across Cloud VPN connections. C. Blocking the overlapping IP space using custom route advertisements prevents routing to those addresses entirely, failing to enable connectivity for the overlapping resources. D. Firewall rules block or allow traffic based on policies, but they do not resolve underlying IP routing conflicts or enable proper routing for overlapping IP subnets.
You need to migrate Hadoop jobs for your company's data science team without modifying the underlying infrastructure. You want to minimize costs and infrastructure management effort. What should you do? The options are: Option A. Create a Dataproc cluster using standard worker instances. Option B. Create a Dataproc cluster using preemptible worker instances. Option C. Manually deploy a Hadoop cluster on Compute Engine using standard instances. Option D. Manually deploy a Hadoop cluster on Compute Engine using preemptible instances.
To arrive at the correct answer, we focus on the keywords migrate Hadoop jobs, without modifying the underlying infrastructure, minimize costs, infrastructure management effort.
The correct answer is option B. Create a Dataproc cluster using preemptible worker instances.
Why is this correct? B. Dataproc is a fully managed Hadoop service that minimizes infrastructure management effort. Configuring it with preemptible worker instances significantly reduces compute costs for fault-tolerant workloads. Why are the others incorrect? A. Using standard worker instances in Dataproc does not optimize for minimum cost compared to using preemptible instances. C. Manually deploying Hadoop on Compute Engine requires high infrastructure management effort and using standard instances results in higher costs. D. Manually deploying Hadoop on Compute Engine increases infrastructure management overhead, failing to meet the requirement of minimizing effort.
You need to deploy an application on Google Cloud that must run on a Debian Linux environment. The application requires extensive configuration in order to operate correctly. You want to ensure that you can install Debian distribution updates with minimal manual intervention whenever they become available. What should you do? The options are: Option A. Create a Compute Engine instance template using the most recent Debian image. Create an instance from this template, and install and configure the application as part of the startup script. Repeat this process whenever a new Google-managed Debian image becomes available. Option B. Create a Debian-based Compute Engine instance, install and configure the application, and use OS Patch Management to install available updates. Option C. Create an instance with the latest available Debian image. Connect to the instance via SSH, and install and configure the application on the instance. Repeat this process whenever a new Google-managed Debian image becomes available. Option D. Create a Docker container with Debian as the base image. install and configure the application as part of the Docker image creation process. Host the container on Google Kubernetes Engine and restart the container whenever a new update is available.
To arrive at the correct answer, we focus on the keywords: Debian Linux environment, extensive configuration, installed Debian distribution updates, minimal manual intervention.
The correct answer is option B. Create a Debian-based compute engine instance, install and configure the application, and use OS Patch Management to install available updates.
Why is this correct? B. Using Compute Engine with OS Patch Management allows automated patch deployment and OS updates for Debian instances with minimal manual intervention, while retaining the extensive application configuration already performed on the VM. Why are the others incorrect? A. Recreating instances from templates every time a new image is available requires unnecessary redeployments and does not leverage in-place OS patching. C. Manually connecting via SSH to reinstall and reconfigure the application every time a new base image is released involves significant manual overhead. D. Restarting a Docker container does not automatically apply OS updates inside the container. The container image would have to be rebuilt and redeployed.
You have an application that runs in Google Kubernetes Engine, GKE. Over the last 2 weeks, customers have reported that a specific part of the application returns errors very frequently. You currently have no logging or monitoring solution enabled on your GKE cluster. You want to diagnose the problem, but you have not been able to replicate the issue. You want to cause minimal disruption to the application. What should you do? The options are: Option A, 1. Update your GKE cluster to use cloud operations for GKE. 2. Use the GKE monitoring dashboard to investigate logs from affected pods. Option B, 1. Create a new GKE cluster with cloud operations for GKE enabled. 2. Migrate the affected pods to the new cluster, and redirect traffic for those pods to the new cluster. 3. Use the GKE monitoring dashboard to investigate logs from affected pods. Option C, 1. Update your GKE cluster to use cloud operations for GKE, and deploy Prometheus. 2. Set an alert to trigger whenever the application returns an error. Option D, 1. Create a new GKE cluster with cloud operations for GKE enabled, and deploy Prometheus. 2. Migrate the affected pods to the new cluster, and redirect traffic for those pods to the new cluster. 3. Set an alert to trigger whenever the application returns an error.
To arrive at the correct answer, we focus on the keywords: Google Kubernetes Engine, GKE, no logging or monitoring solution enabled, diagnose the problem, minimal disruption.
The correct answer is option A, 1. Update your GKE cluster to use cloud operations for GKE. 2. Use the GKE monitoring dashboard to investigate logs from affected pods.
Why is this correct? A. Enabling cloud operations directly on the existing GKE cluster requires no pod migration or cluster recreation, ensuring minimal disruption. It automatically collects logs and metrics, enabling you to inspect logs from the affected pods to diagnose the issue. Why are the others incorrect? B. Creating a new cluster and migrating pods and traffic introduces unnecessary operational overhead and risks service disruption, violating the requirement for minimal disruption. C. Prometheus focuses on metrics rather than detailed log inspection needed to diagnose application errors, making it an unnecessary addition for log investigation. D. Creating a new cluster, migrating workloads, and deploying Prometheus adds unnecessary complexity and potential service disruption without directly providing immediate log analysis capabilities.
You need to deploy a stateful workload on Google Cloud. The workload can scale horizontally, but each instance needs to read and write to the same POSIX file system. At high load, the stateful workload needs to support up to 100 megabytes per second of writes. What should you do? The options are: Option A, use a persistent disk for each instance. Option B, use a regional persistent disk for each instance. Option C, create a cloud file store instance and mount it in each instance. Option D, create a cloud storage bucket and mount it in each instance using XFuse.
To arrive at the correct answer, we focus on the keywords: stateful workload, scale horizontally, same POSIX file system, 100 megabytes per second of writes.
The correct answer is option C, create a cloud file store instance and mount it in each instance.
Why is this correct? C. Cloud File Store provides a fully managed NFS file system that supports POSIX compliance and concurrent read and write access across multiple compute instances, easily sustaining performance demands like 100 megabytes per second write throughput. Why are the others incorrect? A. A standard persistent disk in read-write mode can only be attached to a single VM instance at a time, preventing multiple instances from sharing access. B. Regional persistent disks offer cross-zone replication but still cannot be mounted in read-write mode by multiple instances simultaneously. D. Cloud storage mounted with XFuse is not fully POSIX compliant and performs poorly for high-throughput, concurrent write workloads.
Your company has an application deployed on Anthos clusters, formerly Anthos GKE, that is running multiple microservices. The cluster has both Anthos Service Mesh and Anthos Config Management configured. End users inform you that the application is responding very slowly. You want to identify the microservice that is causing the delay. What should you do? The options are: Option A, use the Service Mesh visualization in the Cloud Console to inspect the telemetry between the microservices. Option B, use Anthos Config Management to create a cluster selector selecting the relevant cluster. On the Google Cloud Console page for Google Kubernetes Engine, view the workloads and filter on the cluster. Inspect the configurations of the filtered workloads. Option C, use Anthos Config Management to create a namespace selector selecting the relevant cluster namespace. On the Google Cloud Console page for Google Kubernetes Engine, visit the workloads and filter on the namespace. Inspect the configurations of the filtered workloads. Option D, reinstall Istio using the default Istio profile in order to collect request latency. Evaluate the telemetry between the microservices in the Cloud Console.
To arrive at the correct answer, we focus on the keywords: Anthos clusters, Anthos Service Mesh, responding very slowly, identify the microservice that is causing the delay.
The correct answer is option A, use the Service Mesh visualization in the Cloud Console to inspect the telemetry between the microservices.
Why is this correct? A. Anthos Service Mesh automatically gathers detailed telemetry, including latency and traffic metrics between microservices. Using the Service Mesh visualization dashboard in the Cloud Console allows you to inspect traffic flows and quickly pinpoint which microservice is causing performance bottlenecks. Why are the others incorrect? B. Anthos Config Management manages cluster configurations and policy enforcement across environments, not real-time performance monitoring or latency troubleshooting. C. Anthos Config Management handles declarative governance and configuration deployment, making it unsuitable for analyzing runtime performance issues or microservice latency. D. Reinstalling Istio is disruptive and redundant, as Anthos Service Mesh already collects latency telemetry automatically without needing a manual reinstall.